So we have an introduction slide, but I guess we can skip it. So yeah, as said, my name is Nico. I'm Cloud Solution Architect, and yeah, this is basically me. And with me today, Phil.
Yeah, hi, thanks for showing up. My name is Philip, as you can see, and also introduced. I'm a father and husband. Spare time, I work at the White Duck, doing some stuff. So, let's go.
Okay, so the goal of the next, let's say, 30 minutes is a little bit to talk about security and also raise security, awareness for security, and yes, it is somehow still required. So we did some kind of security talks for some years now. We started with hijacking Kubernetes cluster, container runtime security, Kubernetes network security, and stuff like this. And now we thought about, okay, let's shift it to the developer side, and let's talk a little about how you, if you're a developer, could easily integrate security without any pain or without bothering any peoples. So the idea is to show you some tooling and best practices to not block any kind of processes, but nicely integrate security. So we have some slides, and then most of the stuff will be real world example. We're doing some live demos and showing you the stuff in real. The tools you're showing are a good starting point. So if you did not yet think about security or your small team, this could be a nice starting point for you. If you have, I don't know, 20 security people in your company, a whole team, building a whole big platform, there might be other solutions for you. So it really depends for the use case. So the ideas we're sharing today is to start slow and then add security on top. So before we start, who is a developer in the room? Oh, so let's say half of the audience. So next question. Who feels confident when it comes to security? Okay, some hands. So it looks we are right, and we need to raise awareness of security still. Okay, cool. So quickly summing up with some basic stuff here, talking some seconds about DevSecOps, what it is. So I'm pretty sure you all know what DevOps means. Now with DevSecOps, it's basically about integrating security in the whole lifecycle of a DevOps journey. So in the DevOps 8, which does it mean? So you should start thinking about security in the planning phase. If you plan a feature, then coding the feature, building the feature, test it, really integrating security in all the stages. So if you plan a feature, think about, okay, is there anything I need to think about in the security phase? If you do writing code, maybe starting with static code analyzers pretty early when you're building the stuff, testing the stuff, not only doing end-to-end test, integration test, but also doing tests in regards to security. And then, of course, also in the ops part, in the deployment operating phase, making sure that you have metrics, logging available to also make sure to integrate security in the whole life cycle there. So it's basically about thinking in all the stages about security. Second really important pattern is shift left. Also not really new one, and this means that you shift all the stuff to early stages, so to the left part of the DevOps 8, and try to integrate it in early stages. So why? Let's think about you implementing a feature. You're building an application, you will try to release it to production, and then security team, whoever comes in and say, okay, we need to stop here, we need to integrate security, and you basically completely break down your release cycle. With shifting left, you can really integrate those security parts in early stages. You're spinning up a pull request, implementing new features, and you're getting a direct feedback loop with static code analyzers, for example, and all other parts here. So it's really about getting the feedback to the developer pretty early when they really implementing the stuff and being aware of what they are doing, and then can quickly fix any security issues. Of course, it also improves overall quality, and with that you also have fewer production issues, of course. So it's not only a thing you could do in regards to security, but also shifting left is always a good idea. So I already briefly mentioned it. If you have a bigger team, you might have your internal developer platform, which is the baseline for all your platform teams or all your development teams. You should really think about implementing security at scale. So not building small pipelines, small steps, building everything every time and in every team, but really integrating security into the platform. So if you have an internal developer platform, you could then really integrate security there as well to make it easy to consume all the security features you have implemented. So we are a big fan of an internal developer platform as it makes sense. So it's basically like with Kubernetes. You're getting complexity, and if you gain any stuff out of this complexity, it's totally fine to go this route. If you just get the complexity and no features you really use, it's not a good idea to build an internal developer platform. It's basically the same we're talking about Kubernetes all the time. Just having Kubernetes because it's cool, you can do that, but otherwise you might find better and cheaper options here. It's the same with internal developer platform. So if you have one, if you decide to go this route in the future, also think of securities there. So this was just to sum up all the stuff to have one baseline. What we will show you today. We have prepared 2 demos. First one is about getting awareness of your dependencies and also your vulnerabilities on your application. To get an automated dependency update with integrated validation. We will talk about software bill of materials, short SBOM, to give you the baseline to check for vulnerabilities. Well, this will be the first demo. And the second one will then be about automatically fixing those vulnerabilities we have found earlier, and also about container image signing to ensure your supply chain security. So this is basically the 2 demos we'll do the next 20 minutes. Everything we will showcase today is just a subset of tools we have decided to show you. There are a bunch of many other tools. They are slightly different other feature sets. Some are pretty same. So make sure to really check out the whole CNCF open source landscape and choose the tool that best suits your use case. So it's basically just some tools we're showing you today. There are others as well. All the slides and demo stuff is available on our GitHub repo. So funny that they say after 10 minutes you don't need to do any photos. You will find the slides there. On the code there, you can basically directly try them out. And with this, I would go over to the demo. As said, we have everything in GitHub here. We have a small application, nothing fancy. Let me show it to you. It's a .NET C# application, basically just exposing an API endpoint. It's basically a weather forecast API. So here we go. So quickly showing you that one, we have 2 dependencies here. We're adding mainly open API on Swashbuckle here for ASP.NET Core. So 2 dependencies, pretty small application, as I said, and we're basically building up, providing an API endpoint for weather forecast. So quickly spinning up the application here to at least show that it is running. Open browser. So if you now go to the Swagger URL, you will see we have just the weather forecast here. Can try it out, execute it, and we're getting some kind of weather data here. So nothing fancy, but it's enough for our application or for our demo here. So pretty small application, not doing much stuff here. So now, as we have shown, we have 2 dependencies in our code, and we have here open pull requests. So first thing we have integrated, it's called Dependabot. It's a tool which is integrated in GitHub. We have just choose it to have everything in one repo here. There are other open source tools like Renovate, for example. And those tools are basically spinning up pull requests if there are any new versions available for you. It's any kind of new version, not just any security updates, every update. So first is you're getting awareness, hey, you can bump specific dependencies to new versions. For example, we have here two, or basically the two for our dependencies we just saw in .NET, and we also have two updates available for a Docker file. It's basically the SDK for the multi-stage build and the runtime then, which we could update. So first step is we have the awareness. That there is an update. So let's go for the Open API one. As said, it's Dependabot, but basically other tools out there as well. You're getting all the details, you're getting the release notes, basically you can jump in the release notes, check if there's anything, any breaking changes, anything you need to fix. But in this case, we have also added some validation pipelines down here. So you see some check marks, some green ones, some skipped ones. The idea is here that Dependabot or Renovate or any other tool opens up the pull request. You have build and validation and test pipelines to really validate this change coming in for the dependencies update. And in the best case, directly close and merge it because everything is green. And then you are able to update your dependencies in small steps, which is always a better idea instead of, I don't know, waiting 2 years, 3 years, and then have a big update with big issues. So, but what are we doing here? And this is configured to every pull request in this repo. We have some checks, which is basically the underlying pipelines we're running. First one is some code scanning. In this case, it's called QL, but still, there are multiple tools. And this is basically a static code analyzer. So with every code change in this pull request, this pipeline gets triggered and gets us feedback if there's any big issues in our code. So once again, if I'm being a developer implementing any kind of features, committing to my feature branch, I'm getting directly feedback, hey, the last 20 lines you have pushed, there might be a security issues, and then you can directly fix it. In this case, it's just a dependency update, so we have no issue. On the other hand, we have also a build pipeline, which is not only doing builds, but doing a little bit more. And to show you what we are doing here, I quickly switch to the YAML view of this pipeline. So it's the Docker build one here, which is, for example, also triggered for our pull requests. So, of course, we're just doing a checkout. Then we're doing a linting on our Docker file. Also important, if there's a change on the Docker file, you get early feedback that there might be some security issues or that you have missed some common best practices. And then, yeah, we doing all the build, login stuff, and the important stuff then starts here. So what we're doing is we are scanning our container images for all dependencies. And this is basically now SBOM. Quickly going to the slides back. If you're talking about SBOM, long software bill of materials, it's basically the list of ingredients of all your software and all your dependencies. So you saw the .NET code, we had 2 dependencies. But in the real world, we have much more dependencies. So because those dependencies have sub-dependencies with sub-dependencies and sub-dependencies. So you are not aware of all your dependencies and possible vulnerabilities without generating a SBOM, because otherwise you don't have you don't see all the dependencies. Nobody knows what sub-dependencies are from any dependencies you use. So it's really crucial to create an SBOM as a baseline to then, for example, do vulnerability scanning, or also if you're building up a product, open source, a product, for example, to do a license scanning to validate if you have any licenses which are not okay for your release. So that's basically the baseline for multiple things. In our case, we will talk about vulnerabilities. Currently, there are multiple standards. So you have to decide which tool you use, which standard you require to integrate into other tools. Could be a bit tricky. Hopefully in the future world it's get a little bit easier here. But just to give you an insight here. So in this case, we're doing it with Strivey from Aqua Security, an open source tool. We're basically scanning the image we have just built and then publish the SBOM to the GitHub repository. We also doing a second scan. This is just to get a better output, and this is what I would like to show you now. If we go back to, one sec. If we go to the summary here, you will see the SBOM output here. This is basically pushed by the pipeline. And then we have a nice list of all our dependencies. And also, once again, an information about any kind of vulnerabilities here. So we see some fixed ones. So these are fixed vulnerabilities which we not yet integrated in our image. We have affected ones which are still open. We can't fix those at the moment. So it's a long list you're seeing here. And most important, this list is mainly any vulnerabilities in the underlying Linux of the container image, not the application itself. So it's a long list. Most of them is fixed. And then we have 2 more vulnerabilities in the .NET runtime. This is basically fixed with the depender board updates open for the runtime. So we can now ignore those because they will be fixed after we merge the pull request. But all the others above here, we are still vulnerable because we did not yet integrate them. And this could be because we're using an old baseline image, but it could also be because, maybe the base image we're using is from a third party and they did not already patched it, and so on. And this is basically, now we are aware that there are things we need to fix, but it's still an open topic. And this is where I would like to hand over to Phil to show how you then can fix these open vulnerabilities. But first, I mean, my part is done. Going back to the pull request, quickly merging it, because of course we would like to hire this open API dependencies. And now basically the pipeline is starting, and Phil will show you all the other stuff.
Okay. Mic out?
Yeah.
Hello, hello. I need my mic. I'm back. Okay. So in the meantime, when the pipeline is running, I can show you the Docker file. Can you see it? Yes. With Docker files, it's always hard in a security game because you're playing this dependency game. In this case, we're using like third-party images provided from Microsoft. So we use the .NET SDK to build the application, and then we're using the ASP.NET runtime to run our image because we need all the application dependencies. What you could also do, which is another way, if you're like bigger, what Nico already mentioned, is if you have a big department, you could also provide your own images and distribute them to your teams. But this is another way of doing it. So there are many ways. For this, we choose this way. We're doing a good, let's say, multi-stage Docker image. So we are really good here. And then what I mentioned before, the dependency game. So as you can see, there was like 60 vulnerabilities in the base image in the ASP.NET. What you can do, there were some PRs for the new image, but could be also that not all vulnerabilities are fixed in that image. Then when you update the image, basically you have to rebuild your whole application again. Could be, I don't know, sometimes I see 1-hour pipelines because of testing, smoking tests, whatsoever. And an easy way, what we want to show today is a nice tool which is called Copacetic. Does anybody know this tool, Copacetic, already? Perfect. 1, 2, 3, around 4. And what Copacetic is doing is, like on the left side, we have built our image in the build process normally. And then what we showed on the pipeline already, we're doing the vulnerability scan on this image. And without rebuilding it, we add the patch layer on the right side for all the vulnerabilities which are fixed. So we don't have to rebuild the image. We just run the Coppa CLI tool, and all the vulnerabilities are fixed by adding just a patch layer. It's maybe not the best way to do it. You could also use scratch images, but for reducing the attack surface on the already built image, it's a really good way. Yeah? By the way, does anybody use scratch images? 1, 2, 3, 4. Okay, so also really less, because it's really hard to build in all your application dependencies. So this is, let's say, one way for doing it. I will show you also the pipeline. we are using, for the vulnerability report, we're using Trivy, and Copacetic has a, let's say, a plug-in template, so you can add all other vulnerability scanners which are out there, but we are using Trivy for our demo today. And as I said, we don't rebuild it, we just patch it. It's using BuildKit to directly patch the image, and then we release it again to the pipeline. But we added this note, for sure, if you patch all those vulnerabilities, the image, again, needs to be tested, but all this build process doesn't have to be done again. And hopefully the pipeline is already done. No, it's still running. I think it's this one. No. Then it's this one here. Okay, we're waiting. Choose another one. Doesn't matter. This one here, wait. Yep. And what you can see here, again, what Nico did is the output. And we can see that we have 47 vulnerabilities. And we have some fixed. Yeah? And then we use Copacetic to run. And then we have the patched image, as you can see here. We just call it patch. We just add the patch tag, doesn't matter. And we reduced all the vulnerabilities to 36 without doing anything. Yeah? So the task, it ran 1 minute, as you can see here. I can show you the pipeline also. So the build process in this case is really small, but in real world would be maybe sometimes bigger. And then we just patch the image because we're just loading the image, patch it, and then release it again to the ACR or container registry. And what we do also here, we're adding the artifacts. So we have the the patched SBOM, we have the original SBOM, we also have the Trivy report as artifact to the registry. And the pipeline is here on GitHub. Basically, as we're using GitHub, Copacetic has an action called Copa. And what we do, again, we just do the report. And then we upload the report. We check for vulnerabilities. And if there are vulnerabilities found here, we just execute the Copa action. And then we log into the registry and then we release the image. So this is all you need to be done. So a few lines of code. And you have at least all the fixes available in your image. Yeah. As you also saw, what I mentioned is that on the pull request, we could also do the same game again, update the images, check if there are any vulnerabilities still, and run our action again. And as last step, what we do, we will sign the image with a tool called Cosign Sigstore. I think we talked before already. Does anybody use it? Okay, 3 or 4 I saw. And what is Sigstore is doing, it's using a keyless signing feature, let's say. What we do here is we take the image, we take the SBOM, we use the public Falsio certificate authority to generate a runtime. On runtime, we generate key pairs. And we are saving the image in the middle. I don't have a laser pointer now, but you see the middle block. We saving our certificate signing. We publish it to the record transparency log, which is a public available store where you can verify the identity of the image. Still have voice issues. I'm sorry. Yeah. Then we have the full cycle. We have we fix the Open API for the application dependencies. We fix the vulnerabilities which are available to fix, and we sign the image with Keystore, so you can verify always what's happening. You can verify the SBOM because we attach it as a test chain to the image. You can download it, verify the SBOM, and everything is easy available for everyone. Okay, I think.
Could show the pipeline steps, huh?
Oh, okay, sorry, yeah, I can do it. I lost my pipeline. Which one was it? I think this one here. Show image. I can also show the pipeline here. Yeah, what we do, we use the cosign action. We use Crane as an open source tool from, I think, Google. We're getting the digest from the image. we download the SBOM, and then we attach everything with cosign together and publish this to the GitHub registry. That's the idea. So also a few lines of YAML code, then you're all done. Okay.
Okay. So I think this is the first talk in our life. We have time for questions, huh? So yeah, to sum up, it was just some tools, some ideas to quickly and easily start into the security world. And so hey, we are many developers who is doing security. It was less, and then for the tools, once again, less people. So it's still a good idea to raise awareness and also to start implementing all the security stuff.
Yes.
Yeah, with this, we have some time for questions, I guess.
Excellent. I love questions. While we wait for some questions to come in, please, scan the QR code. Make sure that you select room K2. That's where we're in. Yeah, that you don't direct questions at speakers in different rooms. That would be awkward. Let's not do that. And because I'm up here, I can ask the first question. So you talked about vulnerabilities fixing, and you actually asked who in the audience does like scratch images.
Yep.
So how does it work for scratch images or distroless images?
Copacetic has also support for these images. So what Copacetic is doing is it uses the package manager to fix those, for sure, the images, but also has support for distroless or scratch images. It's the same, basically, then.
Okay, cool. Thank you. No questions yet. Don't all type at the same time. I mean, you had time left, so you could have done one more demo. If you could have done one more demo, what would you have showed us next?
So last
Maybe
time,
something that wasn't ready for prime time, but now you can talk about it.
Yeah. So normally we would add the step where then really use the image and to show, okay, how it works with the signing part, make sure that the Kubernetes cluster is configured to only trust those signed images and stuff like this. We did it sometimes, some talks ago, and this was completely out of time, so we skipped that one. But yeah, so the idea was the building part, but of course there's a whole bunch of things you can do on the running phase of the application, the container. Yeah.
Right, so next time keep it as a reserve demo if you ever have time
It's
left.
available on
I mean,
YouTube.
It's rare. Oh, exactly. Like that could be a good sort of like shout out. I mean, if we don't have any questions in like when I start my countdown, we stop for an early break. I mean, that's also definitely nice. So like countdown is 3, 2, 1. Did you post it in stage K2?
My God.
It is waiting for. I don't see anything yet.
I can share the question on you.
Sure, and then we'll repeat the question though, because otherwise.
Do you ever find that you use Copa to patch an already patched image?
Patch an already patched image. What is an already patched image?
So you use Copa, you patch an image.
Yeah.
Have you ever had to repatch a patched image with Copa? Have you ever encountered that use case?
Yeah, could be. So if you say you have a longer life cycle of an image application version running on your Kubernetes cluster or where else, could be an option that you, I don't know, fix last week with Copa all the available vulnerabilities or fix vulnerabilities, and then maybe this week, 7 days after, some more fixed, you can run Copacetic again, yeah?
Perfect. Sorry, there seems to be a little connection issue, but we got some questions in right now. We have some questions. Is there a dependable equivalent for GitLab?
Yeah, renovate.
Renovate.
Okay. Well,
Yeah.
that was an easy answer. Thank you for that. All right. How do you cope with vulnerabilities you can't currently fix? That's unfortunately the reality, right? So
Yeah.
is the SBOM enough as a document, or will this create manual work for to document the vulnerabilities?
The idea is there that if you can't fix the vulnerability, you can't fix it. So another way is to deploy this image, and the SBOM, when you download the image, it will be attached to the image. Yeah. Oh God.
Yeah, but I think it also depends on the processes. So you can't fix anything where there's no fix available. There might be use cases you maybe can put in some effort on a web application firewall if it's any kind of API, putting it in front and trying to block some stuff. But I think it doesn't make any sense to block a deployment because of any open vulnerabilities which cannot be fixed at the moment, or it doesn't help anybody. So just being aware of it and then try to somehow fix it, or at least fix it when there's a fix available pretty fast.
All right. One question that I didn't mark as, comes to the main stage, but I thought it was kind of funny, as having worked for Microsoft. People who work at Microsoft or like are Microsoft fans can totally use a MacBook. That's not a problem whatsoever. Microsoft actually supports it. So thank you for that question. I just thought I would answer it. Let's see which one is next. Let's do this one. How does the tool, how does it actually work, copacetic, and how strong is the community behind it? Are you actively involved, for instance, with its development as well, or?
The community is, the community is strong because it's a Microsoft open source tool. So Microsoft open sourced it, and Microsoft is using it internally for all the images. So there's a...
So pretty strong?
Maybe not community, but it's a strong Microsoft...
So let's say on the Microsoft side it's pretty strong. The community needs to grow, I think.
But the community will evolve today, I guess.
But at least there are developers in the back to really work and engage with the project. So community needs to involve, and this is why we're talking about it. But it's not a project where I think there will not be any new features because it's basically the underlying part of any Azure service and Microsoft service.
All right.
And how does it work? Did we answer it? Yeah.
I guess.
Yeah. So is the question still open? How does it work? Yeah?
I mean, try and answer it. Well.
Yeah, so what's it use? It uses the report and it uses BuildKit and then analyzes the images and then uses the package manager of the image. For example, if it's Debian, it uses the app package manager to fix the vulnerabilities if they are available. That's the idea, how it's working.
All right. Maybe an interesting one. Wouldn't patching an image every time a new vulnerability comes out increase the bundle size? Is that sustainable long term?
No.
I think it also depends on how long the life cycle is of your application. So if you're releasing multiple times a week or multiple times a day, I think it doesn't matter. If you, releasing every 2 years, then of course you might need to rethink about patching a patched one. Maybe then you're patching just the first version and just add one layer on top for the runtime. But I think it depends on the use case.
It's also like something you could also think about of copacetic is like there's a really critical vulnerability and you just want to roll out the patch now. So you can just patch it and roll it out, without waiting to rebuild the whole application. Or it could be also a use case. Maybe it's not the best, but it could be used like this to immediately roll out the fix.
I think there's also a common question in all of the ones that I get in my little review queue is how to handle vulnerabilities if you cannot update, how to analyze usage of vulnerable packages.
How to analyze? So the analyze comes from the trivia output. This is the analyze. So that's why you have the SBOM. You see the package, if it's available or not, the fix. And the other one is Docker, you cannot update.
Cannot update means there is no fix available or any, let's say, internal dependency break and change, which shouldn't be the case when you're just fixing something. Then it would be a new version or something with a break and change. I guess it's more about unfixed vulnerabilities. Yeah, basically you have to wait or see if you can work around them somehow.
I think if you can't update, of course, in a dream scenario, we all update all the time, right? Like we check everything all the time, but that's unfortunately not necessarily the reality. And updating can be like a
okay. If you have an older version and there is no fix available, then you maybe have breaking changes. This is nothing copacetic can help you with. This is manual task. So
bad news. Sorry. All right. Excellent. Let's see if we have one more question before we go and switch rooms and figure out which room we want to be in next. Do you see one that sort of stands out to you and you're just like, yes, that's the one that we want to... Which one?
Like the one from Chris.
All right.
But there's no upvote, so we cannot use it.
Well, I highlight it now, so now it's upvoted.
So now it's upvoted.
There's still one in review.
I am trying, I'm only one person here. I'm sorry.
So we are available later for questions, just in case.
Find them in the hallway. But also, it sounds like it would be only a small step to just build the base image yourself.
Yeah, that's what we mentioned. There are several thingies, but you can build a base image yourself, distribute it to all your application teams, for sure. But still, you have to make sure that the base image is not vulnerable. So let's say it's a dependency game. If you use a third-party image, it has vulnerabilities. Your base image has vulnerabilities, but you can use a base image for all applications and patch it every time with copacetic, for example, and roll it out. Could be also. So there are many ways. Listen.
Third-party images.
Yeah, but you can use you can build your image on your own, but your own image can also have vulnerabilities.
Yeah, you own the image, you have the control, but this is for images that are third-party to you.
Yeah.
You're not the image maintainer.
Yeah.
Yeah, but you can also use copacetic for your own base image.
Yes.
If you to just quickly fix them in a 90 build or automated pipeline or something.
Yes.
All right, excellent. Just as an add-on, because that's what I see in some of the comments, is that for your information, based on building on top of the community question, copacetic is also a CNCF accepted project since 2023.
Yeah. You're right.
Well, I am not right. The person who wrote
the person is right.
Thank you, person who wrote that. Well, with that, I really want to thank you. Let's do a round of applause, and I want to see you back at 11:55.